Okay, so hold on a second. Gotta get up the right screen. We have a satellite orbiting at 9,000 miles, and we want to figure out what its distance it travels is if it's, I'm going to find this, if it's orbiting at 40 degrees north. So here's the Earth, okay? And here's the equator, okay? And the radius of the equator is this in miles, 3,963 miles. But if we're up here, and I'm going to draw a picture here, if we're up here at 40 degrees north, so this is our circle at the equator. If we did just a cross section of the Earth, we get the circumference of the Earth at that point. And obviously at the equator, it's the fattest. It's going to have the biggest circumference. But up here at 40 degrees north, so I'm up here at 40 degrees north, this circle is going to be smaller because, of course, the Earth, the globe, gets smaller as it goes towards the top. So to figure out about the satellite that's circling at 40 degrees north, we need to first figure out the radius at 40 degrees north. And we're going to use it to find a couple of things. So here's the first thing. So I'm going to draw a triangle right here. Okay, and this is a right angle. This is my 3,963 because I'm coming off the center of the Earth. If I start at the center of the Earth here, then all the radiuses are the same. And I know what the radius of the Earth is at the equator, this 3,963 miles. I also know that this angle right here is 40 degrees because I said I was at 40 degrees north. I need to know what this radius is. I can use trig to find that. So if I use cosine of 40, that's adjacent, which is x, over hypotenuse, which means that x is 3963 cosine 40. Make sure your calculator's in degrees, because mine's usually in radians, and then so the cosine of 40 is like 0.766 times 3963. So 3,035.8 miles. Okay? And so you can see here, that's, almost 900 miles smaller than the radius at the equator. So it's getting smaller and smaller the farther we go north. And the farther north you went, the smaller the radius is going to be. And the same going south. The radius at 40 degrees south should be the same. We're just going the opposite way. Okay? I could also then figure out the circumference of the Earth at this point. Circumference is 2 pi r. So this is 2 pi times, and I'm going to round to the nearest whole number for all these. So this is 36. So 3,036 times 2 pi gives me a circumference of 19,076 rounded miles. So this is the circumference at 40 degrees north, okay? Now, so we could also, if we wanted to compare this, easily find the circumference of the entire Earth. So the circumference of the entire, not the Earth, the entire Earth, at the equator would be 2, not what I just put into my calculator, 2 times pi times this original one, this 3963. And so the circumference at the equator at its widest is this many miles. So that would give us our comparison. Now I want to know, say I have a satellite up here in orbit, and it's out here at 40 degrees north, and now it's circling, but it's circling out here, and it's 9,000 miles above the Earth's surface. So to figure out the distance it travels around on one loop, I need to find the circumference for this. Well, what's this radius? Well, it's the radius I just found plus 9,000 more. So the radius for my satellite is going to be whatever I just said this was. So 3,036 plus 9,000 miles that I'm going up. So this is 12,000 36 miles is my new radius, okay? That's how far out that satellite is from the center of the Earth at 40 degrees north. And then to find the distance it travels on one orbit, I would again find the circumference. So 2 pi now times 12,036. So 12,036 times 2 times pi, 75,624, depending on how you round. Mine was 0.4, so I'm leaving it there. So one orbit of this satellite at 40 degrees north, that's 9,000 miles up, is 75,000 miles, 624. And so that gives me my the distance it travels around once on my circumference.